Hello everyone and welcome to the video lecture on numerical method. In this video lecture, we will study the concept of numerical method where we will go through the basic terminologies required to understand the numerical method. Then we will see what are its applications in real life. Also, we would like to know what is the importance of numerical method, why one should study numerical methods, and finally we will go through the various types of errors encountered during the numerical computation. So let's see first what exactly a numerical method is. So using mathematical modeling, most of the problems in engineering, physics and economical sciences can be formulated in terms of system of linear or nonlinear equation, ordinary or partial differential equations. So therefore, broadly, a mathematical methods can be classified into two types, analytical methods and numerical methods. In majority of the cases, the solution by analytical methods does not exist, or if it exists, then it is difficult to solve or not amenable for direct interpretation. Whereas the numerical analysis provides approximate solution which are amenable for analysis. Numerical analysis does not strive for exactness. It means numerical solution analysis or numerical methods does not gives us the exact solution. Instead, it provides approximation with the specified degree of accuracy. So numerical analysis is a branch of mathematics that deals with devising efficient methods for obtaining numerical solutions to the difficult mathematical problems. Most of the mathematical problems that arises in science and engineering are very hard and sometimes impossible to solve exactly. Thus, an approximation to a difficult mathematical problem is very much required to make it more easy to solve. Due to the immense development in the computation technology, numerical approximation has become more popular and a modern tool for scientists and engineers. As a result, many scientific software are developed, for instance, MATLAB, Mathematica, Maple, etc., to handle the more difficult problems in an efficient and easy way. These software contains functions that uses the standard numerical methods, whereas a user can pass the required parameter and get the result just by a single command without knowing the detail of numerical methods. Thus, one may ask why we need to understand or study a numerical method when such softwares are always there at our hands. So in fact, there is no need of deeper knowledge of numerical methods and their analysis in most of the cases in order to use some standard software as an end user. However, there are at least three reasons to get a basic understanding of the theoretical background of the numerical methods. Learning different numerical methods and their analysis will make a person more familiar with the techniques of developing new numerical methods. This is important when the available methods are not enough or not efficient for a specific problem to be solved. Second point is, in many circumstances, one has more methods for a given problem. Hence, choosing an appropriate method is most important for producing an accurate result in lesser time. So, selection of appropriate numerical method is very much required. The third reason to study numerical method is, with a sound background, one can use methods properly and or are disadvantages and advantages of that particular method, and most importantly one can understand what is going wrong when results are not obtained as per the expectation. So these are the three reasons why one should study numerical methods, even though the softwares are easily available to solve the problems. So the main goal of numerical analysis is to develop algorithm for computing precise numerical values of mathematical quantities, including functions, integral solution of algebraic equations, solution of differential equations, both ordinary and partial, then solution of minimization problem, and so on. So the objective of interest typically arises in application, which seek not only their quantitative properties but also the quantitative numerical data. The goal of this course or the lecture is to introduce to you some of the important and basic numerical methods that are used in practical computation. Beyond merely learning the basic techniques, it is crucial that an, a learner should understand and develop a algorithm for solving the day-to-day life. So let's see what are the applications of numerical methods in real life. So these are some of the application: estimation of ocean currents. It is used in modeling combustion flow in a coal power plant. Then airflow pattern in the respiratory tract can be studied with the help of numerical methods. Also, the deposition and transport of the chemicals through the body can be studied very well with the help of numerical methods. Then we can have the molecular and cellular mechanism of toxicity analysis very well with the help of the numerical methods. Then the electromagnetic analysis for detection by radar can be done using the concept of numerical methods. Few more applications are structural and mechanical analysis, design and behavior, followed by weather prediction. Then the groundwater and pollutant movements can be studied very well with the help of numerical methods. So these are the few. The application of numerical method is vast. I hope once you understand the concept, you can find yourself the various applications of numerical methods. So let's see some important terminologies. So in numerical computation, the one would finally requires a result in numerical form. For example, a set of tabulated data is given, an inference have to be drawn from it. So a system of algebraic equation is given and one is required to solve them. So the main objective of numerical method is to provide the efficient method for obtaining the numerical answers to such problems. Thus, numerical methods are the methods used for solving the problems numerically, that is, in terms of a number. So basically, in numerical computation, we have two types of numbers: exact numbers and approximate numbers. So what is exact number? The numbers which have finite decimal expansion or representation is called exact number. Whereas the numbers which do not have finite decimal expansion or representation is called a approximate number. So this is an example of exact number, right? You can see here all these numbers have a finite decimal representation. Whereas if I take the example of this 1 by 3, so one can write it as 0.333 10 times, 0.33 20 times, and so many times. Similarly, the value of e pi root 2, that is also having the infinite decimal expansion. As per our requirement for the calculation purpose, we just dominate them up to some digits. So let's see what is digits. So digits which are used to express a measured or calculated quantity in a number is called significant digit or figure. For example, the numbers 89653, 2.8675, then 0.33857, 119.36. Each contains 5 significant digits or the numbers. But if I'll consider the number 0.00896, then second number you can have. So all these numbers have three significant digits, and those digits are respectively 896, then 108 and 985 only. Here the purpose of 0 is just to fix the decimal position. So I hope you must have understood the concept of significant digits or the numbers. Now let's have, so as I said, according to our requirement, we used to retain some digits and discard the remaining digits. So this is called as the round off. So what is round off? The process of retaining the required significant digits and discarding the remaining is called round off. So here we are going to study the rules to round off a given number. So to round off a number to say n significant digits, what we will do? We'll discard all the digits to the right of nth digit, and if this discarded number is less than 5 in the n plus 1th place, then leave nth digit unchanged. For example, the number 3.892, when it is rounded off to three significant digits, it comes out to be 3.89. So the digit which is next to the third significant digit, that is 9, is 2, which is less than 5. So that's why this 9 will remain unchanged. So we have the final rounded off digit as 3.89. The second rule is, if the discarded number is greater than 5 in the n plus 1th place, then increase nth digit by 1. See, for example, if I want to again round off this up to three significant digits, so what I'll do, I'll write 3.89 as it is. Then next to 9, what I have 7, which is greater than 5. So this 9 will increase by 1, so it will become 10. So it means 89 will become 90. So that's why it is 3.90. Now there will be a third possibility that the discarded number is exactly 5 in the n plus 1th place. In this case, increase the nth digit by 1 if nth digit is odd, otherwise leave it unchanged. It means if nth digit is even, then it will remain unchanged. For example, 3.895 will round it off to 3.90 because here it is exactly 5. But before 5, the digit available in the nth place is nothing but 9, which is odd. So it will increase by 1. So it will become 3.90. Similarly, if I'll take 3.885, so this will become, so before 5 what I have, 8, which is an even number. So that's why it will remain unchanged. So up to three significant digit, this number can be rounded off to 3.88. So I hope these rules are clear to you all. Let's move to the one simple example. Here we wish to round off the following numbers correct to 5 significant digits. So uh, retain the number up to 5 significant digits. So it will be 123.43, and after 3 what I am having a number greater than 5, so it will increase by 1, so rounded off number will be 123.44. Similarly, I am having 123.43, I will write as it is. After 3 what I am having 4, so which is less than 5, so this will remain as it is, that is 123.43. Now let's take another case. So again I will write up to 5 significant digit, 123.43. But next to 3 what I am having 5, and 3 being an odd number, so this will increase. So we will have finally a rounded off number as 123.44. Similarly, let's understand this with other with other number, that is 123. I'm having 4 to 5 8, so I'll write up to 4 2, and after 2 what I'm having 5, so this is exactly 5, so I'll see the nature of this fifth digit, right? That is true, even, so it will remain as it is, so 123.42. Similarly, if I round off this up to 5 digit significant digits, so what I see that the number in the fifth digit is this 9, and just after that the immediate digit is 9, so it will increase, so it will go on increasing, and after increasing this will become 10. right? Similarly, you can have the remaining two. So I hope with this couple of examples, you must have understood very well how to round off given numbers. Now let's have the errors in the numerical computation. So here we will first define certain quantities. If x is the true value, say, and xa denotes the approximate value, then the difference of the true value or the correct value with the approximate value is called error. And if I'll consider it absolute value, then it's called absolute error. Similarly, if I wish to find a relative error, so relative error is nothing but the absolute value related to the true value. So that is mod of x minus xa upon x. And if I'll multiply this relative error with 100, then it becomes a percentage error. So these are some of the formulae to calculate the types of errors. Now let's have what are the types of errors which we encounter in during the practical calculations or applications. So the very first error is inherent error. Now what is mean by inherent error? Error which is already present in the data is called inherent error. Means these errors exist in the problem either due to approximate given data or limitation of computing aids or simplified assumptions in the mathematical formulation of the problem or the physical measurements of the parameters of the problem. Now, the question is how do we minimize the errors? So, these errors can be minimized or reduced by using the appropriate data or by providing the high precision computing aids. That's how one can minimize the inherent errors. The next error is round off error. So obviously in computer we represent a number in a finite number of digits and hence some quantities cannot be represented exactly. So the errors caused by replacing a number by its closest machine number is called a round off error. So these errors arises due to the process of round off of a number in the process of computation. The round off errors can be reduced by doing the computation to more significant digits than given in the data at each stage of computation. So the third type of error which we have is called as a truncation error. These are arising due to the use of approximate formula or using a finite series by truncating a infinite series to some approximate terms. So it's very difficult to minimize the truncation error. The only way is to use the more number of terms in the infinite series representation for the calculation purpose. So I hope you must have understood what is the importance and basic terminologies along with the types of error. So in the next video lecture, we shall see the various methods to solve the problems on algebraic and transcendental equation. Till then, keep watching, keep learning. Thank you all for watching the video.